This is lesson 6.1, solving two-step linear equations. A linear equation has variables, numbers, and an equal sign. So here's an example of one right here, 2x plus 1 equals 3. It can have multiple variables in it, but we're only going to deal with equations that have one variable for this chapter. Linear equations are used to represent many real-world situations, and we can solve these problems by solving for the variable, or whatever the unknown is. In order to solve linear equations, we have to know what opposite operations are. These are operations that undo each other. So multiplication and division are opposite operations. For example, if you multiplied something by 2 and then divided it by 2, those operations cancel each other out. As well, addition and subtraction are opposite operations. They undo each other. You may have heard of this in grade 8. So how do we solve a linear equation? If you're asked to solve an equation, it just means to find out what that variable is equal to. You have to perform opposite operations until that variable is on its own, or until the variable is isolated. Whichever operation you do to one side of the equation, you have to also do to the other side of the equation. And when trying to figure out which operation to do first, follow reverse BEDMAS. You can remember this because we're doing opposite operations, so we're going in the opposite direction. So in other words, you're going to do addition or subtraction first before you deal with any multiplication or division. So essentially, to solve equations, isolate for the variable that exists until it's on its own. So then you would have that variable equals whatever number you have, and that's how you solve for the variable. A couple examples. This one first, 2x plus 3 equals 6, definitely on the easier side. So we need to get x on its own. It currently has 3 being added to it, and it's also being multiplied by 2. So we have two opposite operations to perform to get x on its own. So the opposite of adding 3 is subtracting 3. The opposite of multiplying by 2 is dividing by 2. So those are the two operations we have to do. The reverse BEDMAS tells us that we have to do the subtraction first before we do the division. So we've got our equation here. The first thing we're going to do is subtract 3 on both sides, because remember, whatever you do to one side, you have to do. So these just cancel out because we had 3 and then we subtracted 3, leaving us with 2x on its own. And then this just got simplified to 3 because we had 6 minus 3. The next opposite operation to do would be dividing by 2 because we have to get that x on its own. We have to do it to both sides. So then those two cancel out because you're multiplying by 2 and then dividing by 2, and they just cancel each other out. And that leaves us with x equals 3 over 2. This example here, we have 3 operations going on. We have subtraction, multiplication, and division. We'd have to do the subtraction first. We have to get rid of that first. The opposite of minusing 1 is adding 1. So that's what the first operation we would do. These two then cancel out. You have 1 and you take 1 away. And this one just becomes a 9. The next operation, we have multiplication going on and division. According to BEDMAS or reverse BEDMAS, it doesn't really matter which one you do first. I'm going to get rid of the 3 first. I'm going to deal with the division. So if it's being divided by 3, then I have to multiply each side by 3 to get rid of it. So those two cancel out, leaving us with 10x, and then 9 times 3 gives us 27. The last step is to get rid of the 10. It's being multiplied, so the opposite operation is to divide. So then those two cancel out. We've got x equals 27 over 10. You can leave your answer like this in the fraction, but it converts to a pretty easy decimal, so I converted it to 2.7. Either is fine, as long as that fraction is fully reduced, which that one is. Next example, so 15 equals x over 5 minus 10. Have to get x on its own. So the first thing we're going to do is deal with this negative 10 here, because the subtraction or addition will come before multiplication or division. So we have to add 10 to both sides. These cancel out, and the left side becomes 25. Next, to get rid of the 5, we'd have to multiply by 5 because that's the opposite operation. I do that to both sides, and I get x on its own, so x is equal to 125. Last one of this set. we're using y this time. It doesn't matter. It can be any variable or any letter. And now we have some fractions to deal with. So we've got addition and division. Addition has to go first. We're adding a third, so the opposite of that would be to subtract 1/3 from both sides. So these two cancel out. On the other side, we've got some fractions that we have to subtract. Thankfully, they already have a common denominator, so it's kind of easy to just combine them together. But if they didn't have a common denominator, you would have to find one. So -2 minus 1 is -3, so the fraction gets simplified to this. And then lastly, to get y on its own, it's being divided by 4, so we'd have to multiply by 4. Those cancel out, leaving y on its own. We've got -12/3, and that simplifies to -4. So again, you have to have a solid grasp of rational numbers from chapter 1 in order to be able to solve these linear equations. And remember to always fully reduce your fractions. So sometimes the variable might appear more than once. You won't have two different variables, but the same variable might show up more than once. In this case, you just have to collect your like terms until there's only one variable left. Remember, collecting like terms is from chapter 4 on polynomials. So this first example, we've got 2x minus 4x plus 3 equals 11. This is still a linear equation, but thankfully, yeah, we have two variables, but they're the same variable with the same exponent, so we can combine them together, which is what I've done here. We had two x's, we subtracted 4 of them, we only have 2x left. So -2x plus 3 equals 11. Now this is a form we've already worked with. So I'm not going to write it out every single time. You don't have to write out every single operation you're doing. What I've done now is I know this plus 3 is going away because I'm minusing 3 on both sides. 11 minus 3 gives us 8. And then to get x on its own, I'm going to divide both sides by -2. So that gets x by itself. 8 divided by -2 gives me -4. In this example, we have two x's and they're both in fraction form. So in order to collect like terms, we need to find a common denominator so we can combine them. In this case, the common denominator is 6. So we have to multiply the first fraction by 3 on the top and bottom, and the second one by 2, so that they both have a common denominator of 6. In this step here, now they have the same thing, so we can combine them. 3x minus 2x is 1x. So we're left with x over 6 equals 6. Multiply both sides by 6 to get it on its own, the variable on its own. And so we have x equals 36. Some other types of questions you might see, you might have decimals involved in it. Same idea though, just do the opposite operation until you solve. You can definitely use a calculator on this in this chapter. So like if you get a question like this, you can just throw that right into your calculator. Generally for rounding, round to 2 decimal places unless I tell you otherwise. So in this case, we will have to get the m on its own. So we're going to subtract both sides by 2. It gives us 10.4. And then we would divide both sides by 1.5 to get m on its own. And that's when we use our calculator. You also will see some word problems. This is very similar to chapter 5. You need to be able to create the word problem. And then now you're going to also solve for it. So imagine you have $67.50. If a movie costs $8.50, how many movies can you see before you only have $8 left? So the variables we're going to use, m will be the amount of money you have, and n will be the number of movies that you see. So you need to be able to create an equation like this. And again, this is from chapter 5. So how much money you have would be whatever you had originally, $67.50, minus however many movies you see times 8.5. Because for each movie you see, your money will go down by 8.5. Once you have this linear equation, we want to solve for when our total money is just $8. So when m equals 8, what does n equal to? So we replace m with 8 like we've done here, and now we only have one variable left, so we can solve that variable. And that's what I do here. So to get n on its own, first I will subtract 67.5 on both sides, because remember we do addition or subtraction first. So I bring it to the other side and I calculate that I've got -59.5 equals -8.5n. So then I just divide both sides by -8.5 to get n on its own, and I get a nice number of 7. So therefore you can see 7 movies before you only have $8 left. The last part of this lesson is how to check your work. That's what's nice about this chapter is you can finish a test or a project, or assignment, whatever, and always know if you've got the answer right, because there's an easy way to check your work. All you have to do is substitute your answer into the original equation, and then just check that the left side equals the right side. So for example, here, we have our linear equation and we solve for it. We bring the 3 over, we multiply both sides by 2. However we get there, our answer is x equals 20. So how do we check if it's right? Well, take your original equation and take the left side, deal with that first. If the variable's on that side, replace it with whatever answer you had. So we came up with 20. So I'd say 1/2, and instead of x, I write 20 plus 3. And then solve this to see what value you get. 1/2 times 20 gives us 10. 10 plus 3 is 13. So the left side would give us 13 if we subbed in this x equals 20. What is the right side? It's also 13. So since left side equals right side, we can give ourselves a check. We know that we've done this correctly. If we had done this incorrectly, let's say we had got like x equals 16, let's say. If x was 16 and we tried it, we would say, okay, 1/2 times 16 plus 3, this is 8 plus 3, this is 11. That's the left side, but the right side is 13. These do not match. That means we must have done something incorrectly, and then you would go back and check and double check your work until your check does have left side equal right side. So that's what's nice about this chapter, is you can always check if you've done the work correctly.